kita akan masuk the final chapter dalam the final subtopic of chapter 5. Okay, which is state of matter. Kita akan tengok solid and later kita akan tengok phase diagram where I akan teach you guys on how to draw a proper phase diagram. Okay. Right. So a few things yang you need to know. Okay. Cara you nak tahu apa soalan yang akan tanya is based on learning outcome. Apa yang akan tanya dalam learning outcome je akan keluar dalam exam. Okay. Explain the fixed shape of solid. Kita akan explain solid tu macam mana, kenapa dia rapat-rapat ke apa. Kinetic concept of following this process of freezing, melting, sublimation, deposition, which is actually the same thing kita akan cerita juga, which is temperature, kinetic energy, and then maybe intermolecular forces. That's it. These three things kita akan guna and cerita benda yang lain tapi guna benda yang sama. Itu je. And then this is new because you guys akan differentiate between amorphous and crystalline solid. Okay. And then crystalline solid pula terbahagi kepada a few examples where it is have metallic, ionic, molecular covalent and giant covalent. This type of crystalline solid, what you need to know is how it form. Okay, macam mana this solid are. Okay, the metallic, which is metallic bonding ke, ionic bonding ke, molecular covalent bonding ke, giant covalent, and the examples. The examples is very easy. You guys just boleh remember. Okay. So, jom masuk. Kalau ada soalan, cakap saya tak nampak Google Meet korang tu. Okay. So, first thing is, we know solid. It is close together. We drawn this so many times. Korang dengar. Itu kan. So, it is in fixed position. Okay. We are imagining the molecules. Kita imagine it as a ball lah. So, it is fixed together. But remember, even at low temperature, this thing still vibrate. Every atom still vibrate. Okay? Unless kalau dia 0 Kelvin, which is negative 273, where it is zero energy. Okay. So, solid, which is, kalau kita cakap paling keras lah compared to liquid or gas. Okay. These are called phases, which is fasa, the phase of a matter. And these phases are interchangeable. Okay, we already know freezing, melting, boiling, condensation. Maybe a few things in new, which is sublimation or deposition. Okay, contoh sublimation, okay, which is the solid tukar ke gas, which is ubat agat-agat. If I'm not mistaken, saya tak tahu korang panggil apa. Which is kalau korang letak dalam korang punya almari, okay, korang letak ada ubat yang warna kuning, warna hijau, kadang warna pink sikit untuk tak nak bagi lipas masuk. So those ubat, those are the kind where from solid it turns to gas. Okay. While gas into solid, this is tak banyak example. Contohnya like even snowfall, they go through liquid dulu. This one is usually macam you are compressing very fast a gas terus jadi solid. Okay. Semua okay kan? I'm making sure you guys okay. Yes, ubat gegat. Betul-betul ubat gegat. So, solid. So, this is very self-explanatory. You guys are smart students. You guys should be able just to think how to describe a solid. On shape, compressibility is very hard to compress a solid kan? Okay, imagine ice, kita nak compress very hard. Density is very high, okay, the highest. Tapi kita akan tengok anomalous cases of H2O. That's the very special one. Okay. Motion, dia orang vibrate, dia orang tak gerak. Okay. Flow, which is none. Viscosity, which is kepekatan, which is none lah. Dia orang cannot go past each other pun. Dia orang tak gerak. Okay. This is the 4 processes yang kita akan tengok lah. Sometimes dia orang akan tanya and so describe je. It's very simple. Okay, melting, Semua tahu ais ke air. So the thing the point yang you nak cerita, okay? So you are storytelling here. The point yang you nak cerita is about first of all, most of this you terus cerita about temperature. So solid is heated. So the temperature increase. Okay. When kita heat the substance, okay, kita give the energy. So what are those energy will turn? Okay, dia akan in turn bertukar menjadi kinetic energy. The particles will have more kinetic energy untuk vibrate. Okay. So untuk melting, sebabkan dia dari solid kan, solid dia orang tak bergerak. Dia rapat-rapat. So when you applying more kinetic energy, they are just gonna vibrate faster. That's it. So they'll vibrate faster to have enough kinetic energy. So the third point yang akan dapatkan markah is the attractive forces between solids molecules. Okay, these have multiple names. Okay, one of your friend dah tanya tadi one question. Okay, sebelum ni kita dah jumpa, kita call it IMF, which is intermolecular forces. Okay, some of it are also called interparticle forces. Okay, inter is between. Okay, sakit matanya merah ni. Okay, between molecules. Intermolecular forces between molecule. Forces between molecules. Okay. Yang macam covalent bonding, all of those bonding, okay. Ionic bonding ke, covalent bonding ke, metallic bonding ke, those are called intra forces. Intra, which is within, okay, dalam. Force yang di dalam. So untuk this, all I are talking about is the forces between, okay, intermolecular force, which is now we can specify lah, it is an attractive forces between solid molecule. So the point yang you akan dapat is about temperature, kinetic energy increase, and then the point yang you nak cerita is the kinetic energy is enough untuk overcome the attractive forces. That's it. Benda yang sama, you guys akan cerita untuk melting, freezing, sublimation, deposition. Okay. You just tukar lah. So freezing, you tahu dia punya liquid ke solid. So just convert this, vice versa lah. Tukar je. Okay. Just like sublimation and deposition, different. It's just that what are you trying to say is the solid turn into gas without passing liquid state. Okay, and likewise untuk deposition, which is you tukar gas kepada solid. That's it. So untuk this kind of question, kalau sublimation, deposition usually dalam 1 marks ni tentulah. This one ada banyak sikit sebab ada banyak point. 3 point yang you perlu ada untuk dapat full mark. 1, 2 and 3. Okay. So this is the type of solid yang kita akan tengok. We have two. We have amorphous and crystalline. This is just a fancy word untuk cakap, okay, messy, and then this one is ordered, or itu je. Don't worry, it's very simple. Okay, amorphous maksudnya those molecules, or example, this is a solid, right? Those molecules are randomly sorted. Okay, randomly sorted. Dah macam telur katak. Telur katak randomly sorted. Whatever lah, apa-apa bola yang randomly sorted. Basically, you ada kotak, you ada bola tenis, you just campak. You campakkan all the bola tenis in the kotak. This is amorphous. They become amorphous solid, right? This is example. But crystalline, in other hand, is ordered. Okay, this is the keyword untuk you describe the crystalline. Okay, amorphous is the keyword is random lah. So crystalline, what is ordered? Okay, for example, in a kotak, okay, saya suruh korang isi bola tenis, the way you isi is you very particular, you susun one by one by one by one by one, and those order you boleh isi in multiple way kan. You boleh susun in multiple way. Either you nak susun like this, dekat celah-celah dia ke, ataupun like very on top of each other, depends, right? Okay. So itu je. So amorphous and crystalline. Right? Okay. The question usually dia akan tanya the definition of amorphous, solid, crystalline solid, ataupun dia minta pasal metallic bonding punya solid, dan dia tanya pasal dia punya examples. Example is very easy. Okay. So this is the definition: crystalline and non-crystalline. Okay. You just hafal one, you will hafal the other one. Okay. It's a well-defined shape, poorly defined shape, right? Okay. Orderly arrangement ataupun the particles or atoms are in orderly manners. Okay. So this one is lack in orderly. Okay. Contohnya salt yang you guys makan setiap hari, the metals that we pegang, sugar, ice, diamond. Example of amorphous solid, which is charcoal, rubber, and glass. Glass is a special one because glass is not actually tersusun, sebab even though korang ketuk cermin keras kan, cermin korang tak keras, actually those molecules are never fixed together. They don't actually can slip past to each other. This is a very special properties of glass. This is the 4 yang dia akan tanya. Tak tanya satu, dia tanya dua. Itu je. Okay. How to classify the solid? How to classify the crystal in which type of crystal? This is very simple. Just based on dia punya bonding. Kalau dia adalah ionic bonding, okay, contoh NaCl, lithium dengan lithium fluoride, okay, remember, cara nak tahu whether it is ionic or covalent, okay, you tengok dia punya electronegativity value, okay, kalau perbezaan with this and this more than around 1.6 ataupun 1.7, it is ionic. Kalau less, most likely dia akan jadi covalent. Okay. So, the forces holding the unit together. Electrostatic force of attraction, apa tu? It just simple way of saying Na plus. Na plus is attracted to chlorine minus. Just the positive charge are attracted to negative charge. Very itu je. Properties, kadang dia orang tanya, kadang dia orang tak tanya. But just know je lah that untuk ionic solid, okay, is very hard, brittle, high melting point, and poor conductor of heat and electricity. Okay, just imagine garam. Garam kau kecil-kecil tu kan. Kalau korang tumbuk-tumbuk garam tu, dia akan hancur jadi serbuk. It is hard tapi dia senang pecah. High melting point is comparing to others. Okay, maksudnya it's quite hard untuk break the bond between sodium and chlorine. Itulah. Sorry. It's hard to break the bond between sodium chloride and another sodium chloride. Right? So how it forms a crystalline solid? Kalau you guys tengok, mana main cursor ni? Okay, sini. So sodium is plus, chlorine is minus. Okay. In the crystalline, we do not only have one sodium, one chloride. We also have another sodium, another chloride. So how do you want to susun is sodium. So this chloride are attracted to here, while this one you boleh connected to another sodium, and sini boleh connected. So nampak tak? Dia dah tersusun in orderly manner. Okay. And then we have giant covalent bond and molecular covalent bond. Okay. The difference between these two, okay, is covalent bond, which is a bit polar sikit, which is we have covalent bond macam normal lah, carbon semua tu. Untuk molecular covalent solid, we only have dispersion forces ataupun dipole-dipole. Okay. Just most of the covalent bond, okay, I reiterate balik lah. So untuk giant covalent bond, instead of contoh between CH4 they combine dengan another CH4 in a solid, is between, kalau molecular covalent is between, the attractive force is between this. But giant covalent solid is very special sebab in the solid you do not have individual atoms, molecules. In giant covalent solid is in the name giant covalent, all of the atom dalam the solid, mana dia pergi mana, okay. In the solid you have a lot of atom yang semua dia connected together with a covalent bond. Okay, all of these are connected with covalent bond. Okay, for example is carbon. Okay, which is kalau you letak in a small space a lot of carbon and then you put a lot of pressure, you will get diamond, where the carbon start to bond with another carbon, start to bond with another carbon, start to bond with another carbon, which is carbon dia boleh buat bentuk tetrahedral. Tetrahedral. And then dia akan bond with another carbon, and then this carbon yang keliling akan bond to another carbon, another 4 carbon, like that. So you tengok, it is a very strong lah, dia macam dia bercantum with each other. That's why diamond is quite strong. Same as quartz. We have silicon, the ability untuk make multiple bond. Okay. Untuk molecular covalent is where dia tak boleh nak combine, contoh CH4 tak boleh combine with another CH4. Tapi how they are attracted to each other is by dispersion forces ataupun dipole-dipole ataupun hydrogen bonding. Okay, ingat dispersion forces ataupun dipole-dipole, which is the molecules are polar. Okay, they are polar, so they have a temporary dipole moment ataupun they have a temporary charge, which is temporary positive and dipole moment positive and negative. So those temporary are attracted to each other lah, attracted to another one from another point. Okay, so this is the example. Water, which is water dia guna hydrogen bonding. Carbon dioxide, which is a non-polar molecule, we have dispersion forces. Okay, dispersion forces also nama dia yang lagi satu, itu saya dah cerita, is also called London forces. Okay. While finally it's metallic solid, they have metallic bond. Okay, like metals, it is in the atoms are in T's of electrons, where all of the atom yang dalam metallic, contoh metal punya bar ke, metal punya besi lah, right, is how they are connected to each other is diorang punya electrons are in a sea of electron, but it delocalized. Dia boleh gerak from one atom to one atom to another atom. This electron dia boleh gerak freely, whatever dia nak pergi. Okay, so the properties is setengah ada lembek, ada setengah yang keras, right? Like normal metals, normal iron are keras, sodium lembek, okay? Mercury is liquid. Okay? That's why we have low to high melting point. Ada yang dah liquid, ada yang still solid. Good conductor of heat, good conductor of electricity, kita dah bincang why itu. Okay? So kita dah habis yang tadi pasal solid, all of the solid. Okay? And now kita akan masuk ke phase diagram. So phase diagram is kita nak cerita in using graph, kita nak cerita the transition between gas, liquid. Salah. And solid. Okay. These three phases, we can represent any molecules, anything in this. Kita guna this phase diagram. Kita call it phase diagram. Okay, let tengok apa itu phase diagram. In a phase diagram, okay, obviously we have phase. Okay, phase which is a fasa, which is whether it is liquid or solid or gas. Okay. And in a phase diagram, we have triple point and critical point. Kita akan bincang what it is. And then identify, don't worry, it's very easy. Kita akan tengok from the phase diagram. And then kita akan sketch the phase diagram of H2O and CO2. Just take note, almost every single molecule will follow the phase diagram of CO2. Okay, cara bentuknya. While H2O ataupun anything yang boleh buat hydrogen bonding, any molecules that can form hydrogen bonding. One example of molecule yang boleh buat hydrogen bonding is ammonia, yang sometimes soalan tanya, ammonia. Okay, so kalau dia tanya anything, contoh dia tanya carbon dioxide, dia tanya apa lagi, HCl, tanya HCl ke, contoh dia tanya HCl, everything will follow the shape of phase diagram of carbon dioxide. Okay, it's a normal one. Yang pelik bila dia ada hydrogen bonding. That's it. Okay, so nanti kita akan cerita kenapa dia pelik, right? Okay, and then from the phase diagram kita akan cerita dia kenapa bila temperature berubah, okay, ataupun pressure berubah. Okay, remember the gas law, you buat eksperimen kenapa bila temperature berubah. Okay, apparently at all phases those temperature and pressure can affect each other. Okay, so what is a phase? Okay, phase bukannya face muka. Okay, phase, fasa, a homogeneous part of a system contact with other part of system separated from them by a well-defined boundary. What is homogeneous? Homogeneous, it just means same. Okay, sama. Okay, a part of system, okay, so which is for example solid. Okay, everything yang solid dia contact dengan other part of system, contoh dia contact dengan gas dia. Okay, a phase, it is a different phase because dia, even though they contact, tapi you can see a well-defined boundary, okay, where from a solid, okay, you guna mata kasar you boleh nampak that where the solid start, where the solid end, and then where the gas start and where the gas end. Okay, you nampak the separation. Easy enough. Kalau UPS probably dia akan tanya this kind of stuff, the definition, right? Biji mata dia bulu mata. Okay, so but what about a phase diagram? So phase diagram is kita ambil all of those phases, kita cramp it in one graph. Okay, it's a graph that show the condition of temperature. So usually the graph is a pressure versus temperature. Is a graph of pressure against temperature. Kita akan tengok that substance dekat at certain pressure apa dia punya phase, or at certain temperature apa phase yang dia akan ada. Okay, since kita a distinct boundary kan between those. Okay, so the boundary also can be shown in the graph. Okay, this is one example of the graph. Okay, so in the graph where is usually is pressure against temperature, and we have the line. So line ni macam bercabang kan. So this is called a phase diagram, where show that contoh at this low pressure, okay, any temperature kat low pressure, the substance will remain as a gas, okay. Tapi kalau di low temperature, di low pressure, okay, low pressure, okay, tapi at that point we increase the temperature, they still uh they still will remain as gas. Tapi at contohlah dekat same temperature ni, temperature ni, same temperature I would say temperature A, tapi as we increase the temperature, kita same temperature tapi kita increase the pressure increase, the substance will start to tukar phase. So they start untuk menjadi the liquid dekat this phase. So, contoh dekat here, dekat this kind of pressure, so pressure A contohlah, dia dah start jadi liquid daripada gas. Okay. These lines show the boundaries of the phase, the boundaries between those phases. Okay, since we have boundaries, we also tend to have a phase where those at those boundaries. Okay, contohlah dekat sini. Open. So, contoh dekat sini. Ini. The substance, contohlah CO2, dekat this exact temperature, this exact pressure, it is not a gas, this is not a liquid, it is both. It is in what's it, a point where it start to transition from liquid to gas or gas or liquid. But kalau you tengok, you cannot discern whether it is liquid or gas. Okay. Since we have two, we also have a point where both three phases coexist in a peaceful manner, where it is not a gas, it is not a solid, it is not a liquid. Okay. Where kalau kita tengok, we don't know what it is. It is all three state at the same place, where it is in equilibrium. Equilibrium ni maksudnya stabil, which is ataupun stabil lah is the most accurate way untuk describe equilibrium. Dia paling tenang at that point. Okay. At every single substance will have a triple point, where at certain pressure, certain temperature, those substances will not exist as liquid, gas atau solid. They akan all three at the same time in equilibrium. Okay. Another point yang kita ada is a critical point. Apa critical ni? Dia sakit critical ke? It's about dia bayangkan dia sakit critical lah. Where it is dekat graph, okay, cabang yang bawah tu hujung sekali here, whether it is neither liquid ataupun gas, okay, where the density of the liquid here is equal to the gas, the phase boundary disappears. Okay, so here sini you do not know what apa benda yang you ada tu. It is just a critical point where you don't even know whether it is gas ataupun it is liquid, right? So this is the phase diagram of carbon dioxide. Okay, carbon dioxide, we have under normal condition, this is how phase diagram lah. So we have a triple point here. And we have a critical point. Right? Okay. So at the line, we have sublimation or deposition, is where the solid turn into gas. Okay, yang kita cerita tadi. Ataupun at this line, which is melting or freezing, it is solid turn into a liquid ataupun vice versa. And the final one is liquid turn into gas. We have those processes happening at those lines. Okay, the exact line, kalau dekat the exact line, it is both at the same time. Okay, but we don't naturally see lah. Kalau you guys tengok ice melting, we don't actually see at the point where it is ice and also it is water. You akan nampak a part of it ice, a part of it water kan. At the exact point, you don't really see. Okay, this is a phase diagram of H2O. Do you see any different? Nampak tak line O ke B? Okay, cara the slant kecenderungan the gradient of line O and B is different for CO2 and H2O, while CO2 is dia punya line is like this. Okay, kenapa and what is the significance of the line slanted ke kanan ataupun ke kiri? Okay, kalau untuk CO2 we call it is a positive slope, so the slope is like this. So this slope ke kanan we call it as a positive slope. Okay, where the melting point of CO2 increase with pressure. Okay, and solid CO2 is denser than liquid. Kalau you guys tengok, lamanya nak gerak. Okay, as you increase the temperature, okay, and the pressure also increase bila dia nak tukar daripada solid ke liquid. Okay, tapi for ni banyak ni saya nak tekan. Okay, because solid is denser. Okay, the reason is we don't have any extra forces between C double O with another C double O with another carbon dioxide. We only have London forces, which is partial positive charge yang sementara, temporary dipole moment. Okay, so bila pressure tinggi, okay, and the volume low, more solid of CO2 form and more heat energy untuk melt solid. Okay, lagi kuat kita compress this together, okay, lagi susah dia nak tukar jadi liquid. Sebab those are closer to each other kan. Make sense. You compress a lot of thing. Okay, you compress. Jadi dekat. Makin jadi solid lah. Make sense. Right? So this is dia punya explanation of why, okay, kenapa kita increase pressure, melting point pun increase sebab dia jadi a denser solid lah kan. You compress the solid, it should be denser, right? Makes sense. And we are explaining using Le Chatelier principles. Kita akan belajar next chapter. Okay, this Le Chatelier principle is just you trying to explain equilibrium, which is at equilibrium, okay, you're on the happy as equal. Kalau you ubah satu tempat, okay, this is a very simple explanation of Le Chatelier principle. You ubah at one place, kiri atau kanan, the other place, okay, contoh you ubah kiri, the kanan akan also berubah untuk obtain the equilibrium balik. So contoh you ubah ni, ini akan kurang lah, macam contoh lah. So dia akan jadi equilibrium balik. Right. Okay, make sense untuk kita compress anything. Compress a solid, dia become jadi a denser. Okay. You compress aluminium foil banyak kali, dia boleh jadi aluminium ball. Kan, you nampak dalam YouTube or anything like that. Okay. But on H2O, you have a negative slope where dia punya phase diagram is like that. Okay, where lagi kita compress, lagi tinggi pressure, say okay, same temperature. Contoh dekat sini, same temperature, contoh temperature A. Okay, this is pressure kan. You keep increasing the pressure, keep increasing. Yeah, okay, for gas, dia jadi solid. Okay, dia dah jadi ice. You keep compressing those ice, right? At one point, dia akan turn back into water. Okay. And another thing yang kita boleh tengok is ice is less than the water. You letak ketul ais dalam air, ais terapung kan. Where it should make sense kalau solid, which is denser, should be denser lah. Bukan apa, ice tak tenggelam, right? Has a negative slope. Okay. Since water is less than liquid H2O, okay, cara nak explain is usually you akan cerita pasal density of dia punya solid, density, and then you just cakap according to La Chatelier principle. Don't worry, you will understand more once kita masuk chapter 6. Okay. As the pressure increase, the system will reduce the disturbance by shifting the liquid phase occupy a smaller volume. Okay. Sebab dia nak achieve equilibrium balik. Dia nak stabil balik. So, you increase the pressure, the melting point also decrease. So, ice melt at lower temperature. So, kalau, okay, lepas ni, you ambil ice dalam peti ais korang. Korang tengok, even though kalau, okay, pasang aircon kuat-kuat. Okay, jangan buatlah, takut nanti parent korang marah pula. Okay, pasang aircon kuat-kuat, and then start letak chopstick ke, or anything ke. Okay, you letak ais and you punya chopstick dalam peti ais, which is nanti dia orang akan jadi the same temperature. Okay, at one point, dalam peti ais tu, you ambil chopstick you cucuk ais tu, cucuk and you tekan. You will see that those area will start jadi cair. So, dia akan cair dari situ. This is not from the heat of your hand, it is from the pressure of you masuk, okay? It will melt. Okay. So this is the comparison of the two diagram. Question also like to ask, okay, they suruh draw the phase diagram of H2O and carbon dioxide. So you draw, and then they suruh explain, which is you explain by one has negative slope, one is positive slope, and you cerita kenapa, you cerita pasal La Chatelier principles, pressure increase, melting point increase for this. So pressure increase, melting point, point also increase, while here is pressure increase, melting point what? Decrease. Very easy untuk dapat marks. Just remember, untuk any graph, untuk apa criteria of marking a graph? First of all, it has to be the correct graph lah. Second, you punya axis contain a label with the correct unit. Okay, same. Here pun sama. Another thing, you must have a title of your graph. Kalau contoh pressure against temperature ataupun phase diagram pun also can. Ataupun kalau you never kalau tulis pressure versus temperature, this will not accept it. You have to write full, okay, and then the correct graph. That is another part. That is how you get marks from graph. Okay, this is sometimes soalan dia cakap heated isothermally ataupun isobarically. Okay, this is question macam untuk chapter 5.1, which is gas. Ingat tak, Boyles dengan Charles dengan Avogadro, each of those has their each constant. Ada benda yang constant, right? Sometimes ada soalan ke? Saya record lah kelas ni. Right. So this those words, fancy words, just mean that iso maksudnya same, sama. Iso maksudnya sama. So isothermally maksudnya same temperature, which is constant temperature, while isobarically is constant pressure. Barically is another word for pressure lah. Okay. Pressure. Okay. Some question dia tak bagi tahu apa yang constant, so you don't know lama nak guna Charles ke Boyles. So you tak tahu, tapi dia cakap isothermally ataupun dia cakap isobarically, then you know. Okay. That's it untuk kelas kita. Do you have any question?